as you know, we have a lot less integral rules than we do derivative rules, unfortunately, which means that a lot of times when we do integrals, and instead of having just a lot of rules at our disposal that can handle lots of different situations, we have to be more clever in using the limited number of rules that we do have. So a very common thing of what we have to do when we integrate a lot of times is rewrite the integrand to fit one of the few rules that we have. And so it might not initially look like this technique or that technique, but if there's some algebra you can do, either factor something or FOIL something out or break something apart or put something in and take something away or do something of that nature, then it will wind up fitting one of your basic integration rules. This integral here is an example. Let's take a look at it. We have the integral of x plus 3 divided by x squared plus 1. Seems pretty harmless. It doesn't seem that big. If you were just to ask somebody, what do you think might work here, what technique might work, most students would probably say the log rule, and the log rule is not a bad guess because you have a rational function, you have a linear function divided by a quadratic. Looks like it might easily be something like du over u or something of that sort, and so it's worth a shot to see if it's the log rule. But once you start getting into the mathematics, you'll notice that we have, if u was equal to x squared plus 1, the du, unfortunately, would only be 2x. Now, if we just had an x, I could make that into a 2x, but this plus 3 really messes that up. There's no way to fix a plus 3. You can fix coefficients like a 2 by putting a 2 on the inside and a 1/2 on the outside, and that sort of deal. We're very comfortable with that idea, but adding a term can't be fixed. It's just not possible. So what do we do? Well, unfortunately, that means that this is not the log rule. So that's the bad news. But let's think about it a little deeper. Is there something that we could do to this integral to change it, to simplify it or rewrite it or do something to it so that it maintains the same integrand, but it looks a little different? Well, the answer for this is to split up the integrand. This is a common technique that we do quite often. If you have this plus sign in the way right here, what we can do is we can break it apart into two integrals. One integral is x divided by x squared plus 1, and then plus 3 divided by x squared plus 1. It's obviously legal algebra. Of course you can do that. Now, what was the purpose of that? Well, here you go. Look at the first integral. The first integral is going to be a good old-fashioned log rule, right? Good old-fashioned log rule like we would anticipate. And the second is an arctangent integral. You remember the integral of 1 over x squared plus 1 is an arctan integral. Yes, we have a 3, but the 3 is not a big deal. We can pull the 3 out, and so we can finish this guy out. So what are we going to do about the log rule? Well, if the u is x squared plus 1, then the du would be 2x. So if u equals x squared plus 1, then the du would be equal to 2x. I only have an x, unfortunately, but that's not a big deal. I'll put a 2 on the inside because I need one, and this should be 2x dx. And so I have a 2x dx right here, and I'll balance the 2 with a 1/2 on the outside of the integral to maintain, this equality here. So this guy's ready to go. His integral is actually pretty simple. It would be the 1/2 that we had on the outside, and then it would be the natural log of the absolute value of x squared plus 1, of course. All right, and then we'll add to that this guy here. When you pull the 3 out, we would have 3 times the arctan of x. 3 times the arctan of x. 3 arctan of x, and then obviously a plus c because it's an indefinite integral. So we're done. This is the integral. This is the integral of this original expression back here. So what I wanted to point out in this video very simply is that you can still use all of your old basic integration rules, but going forward you're just gonna have to understand you'll need to be much much more clever in your application of these basic rules, and look for ways to rewrite the integran to fit the rules that we do have.